Question 1. Which of the following is a primary advantage of multi-agent systems, MAS, over a single monolithic AI system as described in the study material? Option A. Reduced computational complexity for individual tasks within the system. Option B. Increased robustness, allowing the system to continue functioning even if one agent fails. Option C. Simplified debugging due to centralized control and unified codebase. Option D. Elimination of the need for communication mechanisms between components. The correct answer is, quote, increased robustness, allowing the system to continue functioning even if one agent fails. Here's the explanation. The study material states that MAS offer increased robustness. Failure of one agent doesn't cripple the whole system, as a significant advantage over monolithic AI. Question 2. In the context of Master Claude AI and Agentic Development, what is a key characteristic of agents within a multi-agent system? Option A. They are typically monolithic, single-purpose functions without internal state. Option B. They are always centrally controlled by a human operator, lacking autonomy. Option C. They are autonomous, goal-oriented, reactive to their environment, and often proactive. Option D. They exclusively perform data storage and retrieval, without reasoning capabilities. The correct answer is, quote, they are autonomous, goal-oriented, reactive to their environment, and often proactive. Here's the explanation. The Key Features/Components section defines agents as autonomous, goal-oriented, reactive to their environment, and often proactive, and possessing perception, reasoning, and action capabilities. Question 3. According to the How It Works section, what role does Claude's self-reflection capabilities play in the iterative process of a multi-agent system? Option A. It is primarily used to generate the initial problem decomposition for the entire system. Option B. It allows individual agents to evaluate their own output and refine their approach. Option C. It replaces the need for communication mechanisms between different agents. Option D. It serves as the sole orchestrator, eliminating the need for other agents. The correct answer is, quote, it allows individual agents to evaluate their own output and refine their approach. Here's the explanation. The Iteration and Refinement subsection states, Claude's self-reflection capabilities can be embedded within agents to allow them to evaluate their own output and refine their approach. Question 4. What is the primary benefit of incorporating reflection and self-improvement loops into Claude AI Agentic Development? Option A. To reduce the computational resources required for agent operation. Option B. To enable agents to critically evaluate their own performance, identify shortcomings, and iteratively refine strategies without constant human intervention. Option C. To increase the agent's speed of execution for all tasks. Option D. To simplify the initial prompt engineering process, making agents easier to deploy. The correct answer is to enable agents to critically evaluate their own performance, identify shortcomings, and iteratively refine strategies without constant human intervention. Here's the explanation. The Overview section states that reflection and self-improvement loops enable AI agents to critically evaluate their own performance, identify shortcomings, and iteratively refine their strategies or outputs, leading to more robust and autonomous agents with minimal human oversight. Question 5. In a reflection and self-improvement loop for a Claude agent, what is the distinct purpose of the reflection phase compared to the evaluation/critic phase? Option A. The evaluation phase generates new strategies, while the reflection phase executes them. Option B. The evaluation phase assesses the quality of the agent's output, while the reflection phase analyzes why certain outcomes occurred and plans for improvement. Option C. The reflection phase is where human feedback is always integrated, while the evaluation phase is purely automated. Option D. The evaluation phase is a one-time check, while the reflection phase is a continuous monitoring process. The correct answer is, the evaluation phase assesses the quality of the agent's output, while the reflection phase analyzes why certain outcomes occurred and plans for improvement. Here's the explanation. The key features, components, and how it works sections clearly differentiate these. The evaluation phase assesses the quality or correctness of the agent's output, generating feedback. The reflection phase then analyzes this feedback to understand why certain outcomes occurred, identifying root causes, and devising a plan for improvement. Question 6. A Claude agent is tasked with generating CloudFormation templates. After its initial attempt, an external linter and a simulated deployment, automated tools, identify syntax errors and potential security misconfigurations. The agent then analyzes these findings, reviews its internal reasoning steps, and adjusts its template generation logic for the next iteration. This process exemplifies which aspect of reflection and self-improvement loops? Option A. Human-in-the-loop validation. Option B. A purely reactive stimulus-response model. Option C. Iterative execution driven by automated evaluation, reflection, and improvement strategy generation. Option D. Leveraging reinforcement learning for reward-based optimization. The correct answer is iterative execution driven by automated evaluation, reflection, and improvement strategy generation. Here's the explanation. This scenario directly matches the automated code generation and refinement use case. The external linter and simulated deployment act as the automated evaluation. The agent's analysis of findings is the reflection, and adjusting its logic is the improvement strategy generation, all within an iterative loop. Question 7. When leveraging large language models like Claude for complex problems, why is task decomposition considered a fundamental technique? Option A. It primarily reduces the computational power required by Claude, making it cheaper to run. Option B. It helps manage Claude's cognitive load, overcome context window limitations, and improve accuracy by addressing smaller, defined subtasks. Option C. It allows Claude to generate more creative and diverse responses for multi-step problems. Option D. It eliminates the need for any external tools or knowledge bases in agentic systems. The correct answer is it helps manage Claude's cognitive load, overcome context window limitations, and improve accuracy by addressing smaller, defined subtasks. Here's the explanation. Task decomposition is critical because it breaks down complex problems into manageable subtasks, which helps Claude focus its reasoning power, avoids context window overflow, reduces hallucinations, and leads to more accurate outcomes. It doesn't primarily reduce computational power, but rather optimizes its use for complex tasks. Question 8. In the context of task decomposition strategies for Agentic AI, what is the primary function of a planning module? Option A. To execute all external tool integrations directly without Claude's involvement. Option B. To store and manage all intermediate results from completed subtasks. Option C. To analyze the initial complex prompt, generate the decomposition plan, and manage the execution flow of subtasks. Option D. To serve as a dedicated Claude instance for generating creative content for each subtask. The correct answer is to analyze the initial complex prompt, generate the decomposition plan, and manage the execution flow of subtasks. Here's the explanation. The planning module acts as the orchestrator, responsible for understanding the initial request, breaking it down into a structured plan of subtasks, and overseeing their execution. It doesn't directly execute tools or solely store results. though it interacts with components that do. Question 9. Which of the following is a key benefit of using task decomposition in agentic systems, particularly in relation to LLM characteristics like Claude? Option A. It guarantees a significant reduction in API costs due to fewer total token usages. Option B. It allows for better management of Claude's context window and improves the reliability and accuracy of outputs for complex tasks. Option C. It replaces the need for prompt engineering by automating all subtask definitions. Option D. It completely eliminates the possibility of hallucinations or errors from Claude. The correct answer is, quote, it allows for better management of Claude's context window and improves the reliability and accuracy of outputs for complex tasks. Here's the explanation. Task decomposition directly addresses context window limitations by keeping individual subtask prompts concise. This focused reasoning improves accuracy and reliability, making it easier to manage errors. While it can impact costs, it doesn't guarantee a reduction, as it often involves multiple API calls. Thanks for watching. Please subscribe to my channel.